Hi guys, this is Mrs. Pitchford here. I'm going to teach you lesson 1-4, solving absolute value equations. Your objective is that we can write and solve absolute value equations and eliminate excluded values from our answer. The absolute value of a real number x, written as absolute value of x, is its distance from 0 on the number line. So the absolute value of 4 is equal to 4, and the absolute value of negative 4 is equal to 4 because they're both 4 units from 0 on the number line. We commonly think about this if we were out on a boat, okay, on the water, and if the boat is pulling us, and if we're on a giant sail up here, and if there's a little fishy underwater down here, and if the fishy were 16 feet from the surface, and if we were 16 feet from the surface, we really don't worry about negatives or anything like that. We just kind of say we're both 16 feet from the surface. Or after you go to college, okay, here you are, you're graduated, you have your nice little cap on and your gown on, okay? And you have debt, maybe, hopefully not. Okay, but if you do have debt, then, and then let's talk about later in life, you, okay, over the rainbow, here's you again, maybe with kids, maybe just holding a job, okay? And you have cash, okay? If you were in debt 30 grand, later in life, in your bank account, you have 30 grand. We don't really think about that as negative 30 grand and this is positive 30 grand. We kind of just think about you having a distance from 0. Here you're 30 grand from 0. Here you're 30 grand from 0. Sure, we'd rather have money and be up 30 grand than down 30 grand. But hey, that college got you that great job. Okay? All right, folks. So that common idea of just ignoring a negative, it happens a lot in life. Okay? And so there's these absolute value times. Okay, in the Algebra 2 world now, when we're solving absolute value equations, we first want to isolate the absolute value expression on one side of the equation. Then we want to write out two cases. We want to write the expression equal to a positive value on the right, and we want to write the expression equal to a negative value on the right. Then we're going to solve both cases. All right, so what that means is first get your absolute value bars completely alone so there's no multipliers, dividers, adders, subtractors on the bars, and then take two cases. The first case, you're going to leave the right-hand side positive. The next case, you're going to take the opposite sign of the 5 on the right-hand side, so negative 5. In both cases, folks, you always leave the 2x minus 1 exactly the same, okay? We're not actually applying the absolute value to any of these terms. We're just doing this little gimmick where we take it out, set it equal to the positive, take it out, set it equal to the negative, and that's the only side that we make the change on, okay? Got that? Same, 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 opposite. All right, let's work. Add 1 to the other side. 2x equals 6. Divide by 2. X equals 3 is your first solution. Add 1 to the other side. 2x equals negative 4. Divide by 2. X equals negative 2. Check your solutions. 3 times 2 is 6, minus 1 is 5. Does that equal 5? Yes, it does. Negative 2. Negative 2 times 2 is negative 4. Minus 1 is negative 5. Absolute value of negative 5 equals 5. Yes, it does. Check. All right. Try part B. B has absolute value expression with all sorts of neighbors outside of it. We need to isolate the absolute value expression on the one side of the equation. So let's get that absolute value section alone. I'm going to add 1 and move that over first. I'm not messing with the x plus 2. I'm just kicking these other neighbors away from it. Okay, so add 1 over. equals 10. Get this neighbor away from it. Divide 3. Absolute value of x plus 2 equals 10 thirds. All right. Take the take your two cases, x plus 2, no more bars, equals 10 thirds, and x plus 2 equals negative 10 thirds. All right. And solve. Subtract 2, which is the same as turning it into a fraction and getting like denominators. So it's kind of like subtracting 2 times 3 is 6 thirds. 10 minus 6 is 4 thirds. All right, minus 2, which is the same as subtracting 6 thirds from before. Negative 10 minus 6 is negative 16 thirds. All right, box those up. You should check those answers to make sure that you didn't make any algebra mistakes. All right, part C is to simplify an expression. So what we're going to do for simplifying an expression is just 2 steps. PEMDAS, and then secondly, don't ever distribute into the absolute value bars, okay? What's intended by this expression here is that we're absolute valuing this right here, not that, okay? So don't ever distribute that negative into here. Now, PEMDAS says to work inside the parentheses first, or inside the absolute value symbol first, which is standing for a grouping symbol. It's absolute valuing all of this, not that. So it's grouping all of this. So let's work inside. Do we multiply first or add and subtract? We multiply. Multiplication and division happen before addition and subtraction. So 3 times negative 1.5 is negative 4.5. And plus a minus is the same as minusing. Negative 4.5 minus 2 is negative 6.5. Now take the absolute value of negative 6.5, which is positive 6.5, but that negative is still with us. Negative 6.5 is our final answer. All right. An extraneous solution is a solution derived from an original equation that is not a solution to that original equation. Since the distance from 0 cannot be negative, some absolute value equations, such as absolute value of x equals negative 2, has no solution. Okay? That's because absolute valuing something makes it positive. If this in here was 2, absolute value 2, you would get 2 equals negative 2? No. What other number could this be that could be equal to negative 2? What about negative 2? Negative 2, absolute valued is 2. But 2 does not equal negative 2. There's really no number that can go in here that you can absolute value and have it equal to a negative 2, because by nature, absolute value causes you to make it positive. So the positive of something can't be equal to the negative of anything. So therefore, that's no solution when you have an absolute value equal to a negative. What is the solution of this? Check for extraneous solutions. We are especially going to have extraneous solutions pop up when we have another x somewhere in the equation, like right here. In our problems up above, we only had one x, so there will be no extraneous solutions. Okay, so 3x plus 2 equals 4x plus 5, or 3x plus 2 equals negative of the whole right-hand side. So in math notation, I put a negative and then parentheses, meaning that I'm going to distribute that negative to both of those. Okay, so that's how you do the positive and the negative case when you have more than just a single term on the right-hand side. The positive case, keep everything the same. The negative case, take the opposite sign of everything. All right, so we're going to subtract 4x, and we get negative x, subtract 2, and we get 3. So x equals negative 3. We're going to test that answer. 3x plus 2 equals negative 4x minus 5. And then we want to solve. Add 4x minus 2. We get 7x equals negative 7, or x equals negative 1. All right, let's check negative 3. For negative 3, we're going to substitute it in. Negative 3 times 3 is negative 9, plus 2 is negative 7. Absolute value is to us 7. And then negative 3 times 4 is negative 12, plus 5 is negative 7. That does not work. Try negative 1. 3 times negative 1 is negative 3, plus 2 is negative 1. Absolute value is to a 1. Negative 1 times 4 is negative 4, plus 5 equals 1. So this one works. Okay, try 4 more problems. All right, on the first problem here, we want to do what? Isolate the absolute value. Subtract 9 from both sides. 2 absolute value of x minus 7 equals 4. Divide by 2. X minus 7 equals 2. And then take 2 cases. X minus 7 equals 2. X minus 7 equals negative 2. And solve. Add 7 over. X equals 9. Add 7 over. X equals 5. Okay, both those answers should work. 9 minus 7 is 2. Absolute value is to a 2. 2 times 2 is 4. 4 and 9 is 13. 5. 5 minus 7 is negative 2. Absolute value is to a 2. Same ending. 2 times 2 is 4, plus 9 is 13. So both answers work. Over here on part B, we have an absolute value equal to this expression over here with an x, so we're going to see some extraneous solutions. I can roll right into 2 cases because my absolute value sign is alone on that side. It's isolated. X minus 7 equals 2x minus 13, and x minus 7 equals negative 2x plus 13, where I'm applying a negative and distributing it into the whole right-hand side. All right. The first case, I'm going to add 7 to the other side and subtract 2x to the other side. Okay, so I get negative x equals negative 6, or x equals 6. And on the other side, I'm going to add 7 to get 20. And I'm going to add 2x to get 3x. Divide by 3, x equals 20 thirds. Okay. See if one of these is correct. 6. 6 minus 7 is negative 1. Absolute value is to a 1. 6 times 2 is 12. Minus 13 is negative 1. That one doesn't work. Try 20 thirds. 20 thirds minus 7 is negative 1/3, and 20 thirds times 2 minus 13 is also 1/3. Let me try that one more time. 20 thirds minus 7 is negative 1/3. 20 thirds times 2 minus 13. Okay, because that's still absolutely valuing, I still have to make it positive. So 1/3 equals 1/3, and then we have that they're equal. Okay, so this one checks out, 20 thirds. All right, move on over to part C. Okay. First thing you have to do is isolate the absolute value symbol. So you want to divide by 5. Absolute value of x plus 2 equals negative 3. What do you notice about that? You have the absolute value equal to a negative. That's no solution. There's no number that you can make greater by 2 than absolute value it and have it equal to a negative, because when you absolute value something, it makes it positive, and a positive can't equal a negative. So no solution. Watch out for when you get the absolute value bars alone and have it equal to a negative. Look at D, simplifying. Okay, remember when we simplify, we want to use parentheses, exponents, multiplication, division, addition, subtraction, and we don't distribute into the absolute value bars. Okay, so let's work with parentheses. Parentheses means inside the parentheses, or in this case, inside these absolute value groupings. So the absolute value of negative 5 minus 7 is negative 12. Minus comes down. 11 and 14 gives you 25. Absolute value of negative 12 is 12. Minus sign comes down. Absolute value of 25 is 25. 12 minus 25 is negative 13. Okay? All that we're doing for these is just simplifying, work inside the absolute value symbols, work inside any grouping symbols, and simplify. Only apply the absolute value once you get it simplified to just a single value. Do not apply the absolute value right now and think that you can distribute the absolute value throughout the expression inside the absolute value, okay? You have to wait until it's just a single value, like absolute value of just a constant. Okay, good luck, guys.